Hi, today I'm going to share with you some concepts in electric circuits. I'm going to talk about how to understand electric components with things around us. The reason why I choose this topic is because when I was studying electric circuits, I couldn't understand the concepts very clearly because they were just abstract formulas in textbooks. So I have spent some time trying to understand the concept with easier ideas. So let's get started. My topic is understand electric components with things around us. Resistor. I think most people are familiar with Ohm's law V equals to IR, but we can better understand it with this picture. The water level is analogous to the voltage, and the width of the tube is analogous to the resistance. The higher the water level, the higher the pressure. The narrower the tube, the higher the resistance. The water flows out depends on the water level and the width of the tube. Inductor. Imagine you are riding a bicycle or a flywheel. It's hard to start, but once you've started it, it's hard to stop. An inductor acts like a water wheel in a tube. It preserves the kinetic energy of water flow, thus prevents the water flow rate being abruptly changed. The formula of inductor V equals to L times the I over dt is similar to Newton's second law. F equals to ma equals to m times dv over dt. The heavier an object m, the more difficult to change its velocity. The larger the inductance L, the more difficult to change the current. Capacitor. Imagine you are pulling a spring. It will try to stop being lengthened. And if you lose your hand, it will restore to its original length. A capacitor acts like a rubber sheet. If you apply some pressure, it will bend and stop the water flow. If you remove the pressure, it pushes the water in the opposite direction. A capacitor preserves the potential energy of water pressure, thus prevents the water pressure being abruptly changed. The formula of capacitor Q equals to CV is similar to Hooke's law, F equals to Kx. The stiffer the spring, the more difficult to change its length. The larger the capacitance, the more difficult to change its voltage. Diode. And diode is very similar to a door. We can open a door in a proper direction very easily, but if we're putting a door in the wrong direction, no matter how hard we push it, it never opens unless the door is broken. So a diode only allows unidirectional flow from anode to cathode. Transistor. A transistor acts like a faucet. We can control the water flow rate with a handle. If we close it, the water will not flow. If we open it fully, the water flows to its maximum. If we open it within a range, we can control the water flow rate linearly. This is the end of today's video, and I hope you enjoyed. Thanks for watching.